This task is targeted toward late middle school or early high school geometry classes. It examines the properties of an object called the midpoint quadrilateral and familiarizes students with empirical geometric investigation. These are a few Common Core math standards this task can address. So we've constructed a quadrilateral, A, B, C, D, and on the midpoints of its sides, we've constructed another quadrilateral, E, F, G, H. And in Sketchpad, we can drag the vertices around, we can drag the edges around, all like this. And students are encouraged to come up with conjectures about the relationships between the various parts of this construction and of the midpoint quadrilateral in general. So I've come up with a few conjectures. Let's look at those now. My first conjecture is that EFGH, midpoint quad, is a parallelogram. You can see dragging the vertices around that it does appear to be a parallelogram, and students are encouraged to provide empirical justification for their arguments, so I'll do the same. I measured the slope of the opposite sides of the midpoint quad and found that no matter how I moved the larger quad around, the slopes appeared to match. According to Sketchpad, they match. There is a more formal proof that you could do, which has to do with the diagonals of the larger quad, showing that the triangles made with the diagonals are similar to the smaller triangles, but we're only looking for empirical justification. So that is one conjecture. Let's see. The second conjecture that I had was that the area of the midpoint quad, EFGH, is 1/2 the area of the larger quad, ABCD. Now this one isn't quite as obvious. If you make ABCD roughly into a rectangle, just roughly, it might be a little more apparent why this might be the case. If you imagine ABCD as a piece of paper, you could imagine folding the corners into the center and perfectly covering up the midpoint quad. This one is harder to prove formally, and so another empirical justification might help. I've calculated the ratio of these two areas, the midpoint quad and the larger quad. You can see when we drag these around, the ratio between their areas remains the same, 0.5. Even when we drag the vertices and make the larger quadrilateral not even a simple polygon, and not a convex polygon, the ratio between the areas is invariant, according to Sketchpad. So my final conjecture is that the perimeter of the midpoint quad is equal to the sum of the lengths of the diagonals AC and BD. So let me just show those diagonals drawn in. This one I noticed when I was coming up with the formal proof for the first conjecture. Just double checking my work. I noticed that this small triangle is a 1/2 scale down similar triangle to this larger one. ABC is similar to EBF, and the length EB is 1/2 of the length AB because E is the midpoint. And so we can see that EF is 1/2 the length AC. And going around the quadrilateral and all these triangles here, here, and here, we can see that EF is 1/2 of AC, GH is 1/2 of AC, FG is 1/2 of BD, and EH is 1/2 of BD. So the perimeter, all 4 of these sides added together, is going to equal the sum of AC and BD, the lengths of AC and BD. And once again, just with these measurements added in, you see that the sum of the lengths of the diagonals here matches with the perimeter of the midpoint quad. Even when it's dragged around into unusual quadrilateral shapes. So those are my conjectures for the midpoint quadrilateral.